Welcome back, guys. This is Math 024, Module 5, Video 2. And in here, we're going to look at how to solve systems using substitution or elimination. The first video, we looked at graphing, and now we're going to start with substitution. And in order to do substitution, what you're going to do first is you have to solve one equation for one variable. So you want to make it either like x equals or y equals, or whatever your variables are. And then you're going to take that equation, that y equals, and you're going to substitute it into the other equation and then solve for that one variable. So basically, you're going to turn in one equation to only having one variable. And then once you find out what x or y is, then you're going to substitute it back into another equation, into either one, to find the other variable. So if we take a look, for instance, if we look here at A, this one's nice for us because it's already set up. It already has an equation solved for a variable. So we have y equals 2 minus x. So what we're going to do is, instead of putting, what we're going to do is, since we know y equals 2 minus x, we are going to put that in for y in the other equation. So we're going to do 3x minus, and then in parentheses, 2 minus x. So again, I substituted for y, 2 minus x, because we know that's what it equals negative 2. And when I do that, if you notice now, I only have one variable, x. So I can solve this. I'm going to distribute that negative. So I'm going to get 3x minus 2 plus x equals negative 2, because two negatives make a positive. That's how I got positive x. 3x plus x is 4x. So 4x minus 2 equals negative 2. We'll add 2 to both sides. So we get 4x equals 0. And then if we take 4x equals 0, divide it by 4, we get x equals 0. And that is a perfectly valid answer. So now to find out what y is, what we can do is go back up to the easy equation. So let's plug in, I'm just going to move it over up here. So I'm going to say I know y equals 2 minus x. We know that x is 0. So instead of that x, I'm going to plug in a 0. So now we know y equals 2. So the solution to this system is going to be x is 0 and y is 2, or 0, 2. All right, now, if we look at B, this one is a little bit more complicated. We don't have, x or y solved for in either equation. So again, you can pick what you want to solve for. I'm going to look at the first equation. I think the 6x plus 3y equals 12 will make it a little bit easier to solve for a variable. So I'm going to solve for, let's solve for y. So if I solve for y, that means I have to subtract 6x from both sides. So I'm going to make it y equals. So right now I have 3y equals negative 6x plus 12. Trying to keep it in slope-intercept form. I'm going to divide everything by 3, so I get y by itself. So now I have y equals negative 2x plus 4, because 12 divided by 3 is 4. All right, so now we have a y equals equation, which is excellent. And I'm going to take that and plug it into my second equation wherever there is a y. So I'm going to have 9x. Actually, let me make it blue. All right, so we got 9x, and I'm just going to write over it. There we go. 9x plus 6, and then instead of y, we're going to put negative 2x plus 4, because we're going to substitute it in there, equals 15. So now we're going to distribute. So we're going to have 9x plus negative 12x, and then plus 24 equals 15, or 9x plus negative 12x is going to give me negative 3x plus 24 equals 15. So we'll subtract 24 from both sides. and that's going to give me negative 3x is equal to, let's see here, 24, positive 15 minus 24 is going to give me negative 9. Divide by negative 3. So we're going to get x is equal to 3. And then what we need to do is we need to plug in our 3 into one of our two equations. So I'm just going to make a little bit of space. I don't know, I'm going to erase up here too so I can plug it in. All right, so it doesn't matter which equation. I'm going to go back up to this top one. All right, so x is 3. So I'm going to do 6 times 3 plus 3y equals 12. 6 times 3 I know is 18. So now we have 18 plus 3y equals 12. I'll subtract 18 from both sides. So now I have 3y equals 12 minus 18 is negative 6. Divide by 3. And y will equal a negative 2. So our solution to this system, which I know my work is kind of crazy and all over the place, is x was 3, so it's going to be 3, and y was negative 2. So our answers are 3, negative 2. Okay, now we're going to take a look at two more for substitution. And the first thing we're going to do with C is solve for one of our variables. And I would probably say this first equation here, because you have that y without a coefficient, it'll be easier to solve for y for that one. So I'm going to take my 3x minus y equals 4, and I want to solve it for y. So I'm going to subtract 3x from both sides. And that leaves me with the opposite of y, or negative y, is equal to negative 3x plus 4. Now I do need to get rid of that negative sign with the y. So remember, it's just like having a negative 1 there. So we're going to divide everything by negative 1, which really means we're going to change those signs on the other side. So y is going to be equal to negative or positive 3x, because negatives, two negatives make a positive, and then a negative and a positive will make that a negative 4. All right, so let's take that and plug it into our 6x minus 2y equals 4. So we're going to do 6x minus 2 times, and instead of y, again, we're going to plug in to the y, the 3x minus 4, and it will be equal to 4. So we have 6x minus 6x plus 8 equals 4. So now when I go to solve this, 6x minus 6x, that equals 0. So my x's cancel out, and I'm left with 8 equals 4. So in this case, does 8 ever equal 4? And I hope you're like, no, it does not. And you are correct. So for this one, because it worked out where the x's dropped out and we have no variable left, this one is no solution, because we know 8 does not equal 4. And this means that these two lines right here are parallel lines. So they are parallel lines. All right, let's take a look at D. Now for D, I would honestly, I don't like working with those fractions. And so the first thing I would do is clear the top equation of your fraction. So multiply by the common denominator, which in our case is just a 3, because it's the only denominator. So we'll multiply everything by 3. 3 times 1/3 will equal a 1. So we have x minus, and then we have 3y, because 3 times y, and then 2 times 3, so it equals 6. Now, I want you to take a look here. Notice when I rewrite those equations, I now have, because I cleared the equations, I have two exact equations. So when this happens, or if you solve it. And if I were to go through and like solve this, I would get like 5 equals 5 or 2 equals 2. If I get two numbers without a variable that equal the same thing, this means because they're exactly the same equations that their solution is, you know, an infinite number of solutions, but they are the same line. So just like we saw before when we graphed and it was just that one single line, this is the same thing here. Okay, now we're going to look at our second, or actually our third, way of solving systems, our second on this video, and that is through elimination. It's also sometimes called the adding method, so either one. What you're going to do here is you are actually going to add up your two equations so that you eliminate one of the variables. So the first thing you have to do is look at your equations and see, do I need to multiply one or both of the equations by a number, a non-zero constant, to get opposite terms of one variable? And if I do, you know, we can multiply just one equation by something, or we can multiply two equations. It doesn't matter if you do only one or if you do both equations. And once you have opposite variables, and you'll see what I mean in a second, then you add the equations. You don't want to deal with fractions or decimals, so you can clear them out by multiplying by either an LCD or a power of 10, and I'll show you that on the last slide today. And then once we solve for one variable, we're going to substitute back into one of our equations to find the other variable. So if we take a look here at A, notice if I were to like add those up, if I set it up like an addition problem here, I have y and negative y. If I add those together, they're going to cancel out. So the nice thing is I don't need to multiply my equations here by anything. Y minus y is 0, so which is what I want. I want to get rid of one of my variables. And now I have x plus 3x. So it's going to give me 4x equals, and then 2 plus negative 2 is going to give me a 0, which is okay. And then I'm going to divide both sides by 4, and I get x equals 0. And now that I have 1, I just plug in that 0 into one of my two equations. So I'm going to just erase that so we can see it. So I'm going to plug it into the top one because it's easiest. So 0 plus y equals 2. So we know that y equals 2. So the solution to this equation is using the addition method, 0, 2. Okay, so, and that is the same one that we used for substitution, or very similar to it, as the same solution, but just a different way to look at using that elimination. Okay, so now if we look at B, for this one, I don't have any variables right now that I could, if I add them together, would cancel out. I have like 4x and 7x, and then I have negative 3y and 5y. Because my y's are a positive and a negative, and I want them to be opposite signs, I'm going to make those the ones I cancel out. So I really need like an LCD between 3 and 5, and that's going to be 15. So for the top equation, I want to turn that negative 3y into negative 15y. So I need to multiply everything by 5. And when I do that, I'm going to move it up here, I am going to get 5 times 4x will give me 20x. 5 times negative 3y will be negative 15y. And then 5 times 7 is 35. Now the bottom, I want to make that 5y a 15y. So I'm going to multiply everything by 3. So 3 times 7x is 21x. 3 times 5y will be plus 15y. And then 2 times 3 will be 6. So now that I have opposite y values, I can add the two equations together. So 20x plus 21x will give me 41x. And then my 15s will cancel out. So my y's cancel. And then 35 plus 6 will give me 41. And then solve for x, so I'll divide both sides by 41. And x will equal a 1. So that's nice. And then I'm just going to plug that 1 into one of the equations. And I usually go back to the smaller ones. It doesn't matter. You could go back to the smaller ones. You can use one of the bigger ones you created. But I'm going to go ahead and plug it in here. So I'm going to do 7 times 1 plus 5y equals 2. So 7 times 1 is 7. 7 plus 5y equals 2. We'll subtract 7 from both sides. So I have 5y equals negative 5. Divide both sides by 5, and I get y equals negative 1. So my solution to this system is 1, negative 1. Okay, now we're going to work on C. And let's see here. This time, we have two equations where neither of them, like I can't just add them together right now and have them cancel out. But I'm always going to try to go for the smaller values. So I think I'm going to take that negative 3y and positive 4y and turn them both into 12s because that's their least common multiple. So I need to multiply this top equation by 4. So I need to multiply everything by 4 there, and the bottom one, everything by 3. So that will give me on the top, I will get 36x minus 12y equals 48. And then on the bottom, I will get negative 36x plus 12y equals negative 54. So now when I go to add this one, look at this, it's unique. Notice my 36x's cancel because positive 36 and negative 36 equal 0. My negative 12y and my 12y cancel, so I have a 0 on this side, and 48 plus negative 54 is negative 6. So this is similar to what we saw with substitution. Does 0 ever equal negative 6? Hopefully you're shouting no. And that means that these two equations form parallel lines. Oops, parallel lines. So there is no solution. All right, let's look at D. So I think here, again, we have 4 and we have 6. So I'm going to make it into 12. So I'm going to worry about the, let's see, we either have both positive or both negative. So let's worry about the x's. So I'm going to do 4, I need to make this, I'm going to make the top one a negative 12. So I'm going to multiply everything by a negative 3. And the bottom I'm going to make a positive 12. So I'm going to multiply everything by 2. So when I do that, I get negative 12x plus 18y equals negative 24. And then on the bottom, I get 12x minus 18y equals positive 24. All right, so this one, similar to the other one, when I add them together, my 12s cancel out, my 18s cancel out, so that leaves me with 0 on this side. But now look, negative 24 plus positive 24 is also going to give me a 0. So when you have 0 equals 0, or you get 2 equals 2, or something like that, that works. So this means these two equations here are the same line, and your answer can be all real numbers. And that says same right there. I noticed that doesn't look so good, so let me fix that. It's the same line, so it's one single line. All right, we have our last two for this section. And then in video 3, we'll deal with applications of systems. So again, with E, we did not want to deal with fractions when we do elimination because adding those together is a pain in the butt. So what we're going to do is we're going to get rid of any fractions in our problem by multiplying by a common denominator for that equation. And in this case, because 4 is my only denominator, I'm going to multiply everything in this equation by 4. So I'm going to end up with 4 times 2x is 8x. Minus, if you do 4 over 1 times 3/4, you're going to end up with 3y. And then negative 3 times 4 will equal a negative 12. And then for my other equation, we have 9 and 3. So my common denominator here would be a 9, or the least common. So I'll multiply everything by 9. So we end up with 9x plus, when you do 9 over 1 times 1/9, you end up with just y, or 1y. And then 9 over 1 times 13 over 3 is going to give us 39. Because you would multiply 13 times 9 divided by 3, it equals 39. All right, so now we have our two equations. We got rid of the fractions, but just yet we can't, we don't have anything that we can add together to eliminate. So I have that negative 3y and a positive y. So let's just take this bottom equation and multiply it again by 3 so that we can have something to add together. So I'm going to rewrite my 8x minus 3y equals negative 12. And then when I multiply this bottom equation by 3, 9x times 3 will give me 27x plus 3 times y is 3y equals, and then 39 times 3 is going to equal 117. So now when I add my equations together, my y's will cancel. 8x plus 27x is going to equal 35x. And then negative 12 plus 117 is 105. We'll divide both sides by 35. And we will get x equals 3, because 105 divided by 35 is 3. So now to find y, I'm going to go back to one of my two equations. I'm probably going to go to, I think this one is the easiest right here, the 9x plus y equals 39. And I'm going to plug in my 3. So I'm going to do 9 times 3 plus y equals 39. Oops, 39. So 9 times 3 is 27. So 27 plus y equals 39. Subtract 27 from both sides, and we get y equals 12. So the solution to this system is 312. And now I am going to do a little bit of erasing to have room for the other one. So if you need to, pause and write it down. And let me just erase this over here so we have space. All right, so we can start on our last one. Okay, so here we are going to first eliminate our decimals by multiplying by a power of 10. That will help us get rid of the decimals we have. So for the first one, they all go out to the hundredth spot. So we're going to multiply everything by 100. And 2 hundredths times 100 will give me 2x. 4 hundredths times 100 will give me plus 4y. And 9 hundredths times 100 will give me 9. And then for the next one, they both go out to the, or they all three go out to the tenths. So let's multiply that one by 10. So now we're going to have negative 1x plus 3y equals 8. Okay, and we need to eliminate one of our variables. So I think, let's do this bottom one. We already have a positive and a negative. Let's multiply it by 2. So that is going to give me, and I'm going to rewrite the whole thing. So I'm going to have 2x plus 4y equals 9. And then 2 times negative 1 will be negative 2x plus 6y equals 16. Add them together, the x's will cancel. 4 plus 6 will give me 10y is equal to 9 plus 16 is 25. Divide by 10, so y equals, and I'm going to simplify the fraction, but leave it in mixed form. So it's going to be 5 over 2. And then we do have to find x, so let's go up, and I'm going to go to this equation right here. I think it'll be the easiest. So we have negative 1x plus 3 times 5 over 2, and again I can make that 3 over 1, equals 8. So now I have negative 1x plus 3 times 5 is 15 divided by 2. So we have 15 divided by 2, or equals 8. Or I can make it negative 1x plus 7.5 equals 8. Then we'll subtract 7.5 from both sides. So we end up with negative 1x equals 5/10. And then we're going to divide it by negative 1. So x equals negative 5/10, or negative 1/2. And so our final solution for this system is negative 5/10 and 5/2 for y. And that is it for this video. Stay tuned for applications.